Today is November 20th. And these are warm-ups. I thought I'd give you some warm-ups because you have a couple of assignments to work on today. You have the one on the Delta Math, which you might very well already be done with. And then there's a new one that is a PDF that is posted on the old Canvas. So I thought I'd warm us up. And there's a little new something in here too. So 3 warm-up problems just to get our brains going from the weekend. So here you go. Here's the first one. Each one of these warm-ups serves a different purpose than the others. If you were not here Thursday, I just have to assume that you've already watched the instructional video. So here we go. Let's get to it. What is the first thing we would do on this one? We know that we want to get rid of the 4 first because the -2 is attached to the variable part. And so we will get rid of the -2, but like any equation, dividing by him will be the second thing that we do. So let's start off by, I'll show a little bit of work by subtracting the 4 away to both sides. So those 4s, huh? Well, they shut theirs, so let's see how it goes. If the ruckus continues, then yeah, let's close her up. So we're left with -2 times the absolute value of 3x plus 5 is equal to -12. We're not quite there yet. What do we do now? Right, and so if we divide both sides by -2, like this, then we get to the part of the problem now where we want to be. We have the absolute value of 3x plus 5 equal to 6. And you'll recall, I think the way I explained this to your class on Thursday was kind of like whether you draw it physically or just in your mind, you set a stopping point there. This is the part where you pass judgment on the problem and say, should I proceed or should I stop? And what would we do with this one? We would proceed because the absolute value of 2 different numbers could equal 6. And remember, those numbers are what we base our equations on. So one equation says stuff inside the absolute value, maybe u equals 6. Or the other side of it is we say stuff inside the absolute value, maybe u equal -6. And we understand that those are both legitimate scenarios. The inside of those absolute value bars could equal either of those numbers, and the equation would be happy. So far, so familiar, I assume? Looking familiar? Okay. And then from here, you do have to finish the job, of course. Remember, you cannot solve the white equation. You can only convert it to the purple equations and then proceed to solve them. You don't solve equations that have absolute values. You convert them and then solve. So on this one, we're going to take away 5 from both sides, leaving us with 3x equals 1, and then divide by 3, and we get one of our answers, which is x equals 1/3. And then on the other side, we would get 3x equals -11, and then we divide by 3 and get x equals. Yeah, so these are the solutions to that white absolute value equation from up at the top. Any questions there? That's what we talked about Thursday. All right, let's take a look at the second one. So we have -6 times the absolute value of x minus 9 plus 10 equals 10. What would we do first here? Yeah, the same thinking applies. Like we know the -6 eventually has to go poof, but that's just fundamentally not the first thing we would worry about. We got to take 10 away from both sides. So if I subtract 10 on both sides, then I'm left with a 0, which is why this example is in here. And I feel like maybe this showed up in your notes. I don't think I used the exact same examples top to bottom Thursday and second and fifth hour. So you guys may have already seen this, but what do we do now? We divide both sides by -6. And when we do that, then we're left with, again, we are at the place where we want to be, which is absolute value by itself is equal to a number. And again, we stop at this point and we pass judgment. This is the part where you say to yourself, do I proceed with writing 2 equations? Do I proceed with writing 1 equation? Or do I just stop and write no solution? Which one is this?
1.
Yeah, good. So did this come up? Was this an example on Thursday? If the absolute value equals 0, I mean, let's think about this for a second. If I vandalize this, and let's just pretend that you did not know what was under the vandalism. There's only one number that could be under the yellow scribbles, right? There's only one number in the universe that has an absolute value of 0 is 0. So the only equation that we can / have to write here is x minus 9 equals 0. The white equation and the purple equation are not the same. I need you to understand and respect that if I see you taking that white equation and adding 9 to both sides, I'm going to ding you for that. This white equation up here is not manipulatable, solvable. Like x and 9 are not free to move about the cabin because they're trapped. Once we convert them into a normal equation, that's when we're green lighted to solve. So in this case, we only get one answer, and it is x equals 9. Right. 9 is the only number in the world that can solve this equation because there's only one equation that this situation can spawn. So far, so good. Of course, the third possibility is why this third example exists. And I also think we've talked a little bit about this, but you probably already know where this is headed. But let's get it here, make it official, then I'll stop the recording and you'll have some work time today. So here we have -5 minus 3 times the absolute value of 4x minus 1 is equal to 10. Sorry, we got to just keep hitting these fundamentals. If your first thought has anything to do with the -3, you're just not trying hard enough to listen. What do we have to do first? Yeah, get rid of the -5. And since he's not an attached -5, we have to add 5 to both sides. So this time I'm going to show a little less work. I'm just going to put down what I know would be the case. And I add 5, I'm going to get 15. And everything still looks fine. What do we do next?
But you already added 5.
Because you have to make the -5 go away. That's what I get for not showing my work there. And now what do we do? Yeah, and when you divide both sides by -3, I might as well just show my work here. Why I would try to save that time. And then here we go. We're left with the absolute value of 4x minus 1 equals -5. And remember, this is the time, I don't mean to be a broken record, but it's what I do. This is the time where you make your judgment call. You will either spawn 2 equations, 1 equation, or no equations. What's the case here? There are no equations. This equation is literally impossible to solve, not just in Mr. Ahern's class. Absolute value can never create a negative answer. It's this number over here. If this number is negative, once you get the absolute value by itself, right? Once you get it by itself, if that number is negative, then your answer will always be no solution. The equation up there literally cannot be solved. You could sit here, you could spend 1 trillion years putting numbers in place of x and keep multiplying those numbers by 4 and taking away 1 and then taking the absolute value. It's never going to equal -5. What is the lowest output that an absolute value can ever give? 0 is the lowest he'll ever go. If you ask him to give you anything lower, he will break down and say, I can't, right? If the number over here is equal to 0, then there's the one equation, one solution. And if the number over here is positive, then there are two solutions. Got it? But everything I'm saying is based on once phase one is complete, once the absolute value is by himself, that's when you make that judgment call. Any questions about that? All right. That's what you're doing. How many of you are done with number whatever, 19, I think it was, in Delta Math? Okay, finish that one up first, and then when you're done, head on over to Canvas, and the new assignment is a clickable PDF there. Same drill, separate paper. You know what to do.